This paper is about beat perception, isochrony perception, and statistical learning, trying to disentangle these three, with beat perception being defined as a cognitive skill that allows us to sense a regular pulse in a varying rhythmic pattern. It's interesting for multiple reasons. One being that it is universal in the sense that most musics appear to have a regular pulse, allowing for people to synchronize while they make music or dance together. It's spontaneously developing in the sense that it emerges early in life without any explicit instruction. It appears to be domain specific. It's mostly active in the auditory domain in music and less so in language. And it appears to be species specific. Not all animals have beat perception, but just a few, suggesting a number of biological constraints. And these can all be informative for beat induction as a fundamental musical trait that must have played a decisive role in the origins of musicality. I'm going to present a novel paradigm because there was some critique by ourselves and by others on these earlier paradigms because there might be possible confounds, which is in a way relatively simple. It's an oddball paradigm with once in a while a deviant, and the patterns are generated using this as reflected here in this transition network, where there A stands for an accented event, U stands for an unaccented event, and D stands for a deviant. Using this description, we generate a stream of events, a rhythmic sequence, and we present those in two conditions, an isochronous condition at the top and a jittered condition. Both have the same events in the same order, only the timing is different, being isochronous in the top one, allowing for a beat to be induced, and disallowing beat and bass perception in the jittered condition. This setup allows us to test four hypotheses. Auditory perception, then we expect a mismatch response for all deviants, irrespective of the condition. Isochrony perception, then you would expect overall largest mismatch responses in the regular as opposed to the jittered condition. Beat perception, then we would expect on top of that a larger mismatch response on the beat as opposed to the offbeat. And we can test for statistical learning. So the listeners might have picked up these transitions probabilities, and then you might expect a significant difference between the so-called beat and offbeat positions in the jittered condition. We will present results of adults confirming all four hypotheses. We present results in newborns using the same paradigm, confirming three of the hypotheses, not the statistical learning one. And we present these results for two macaque monkeys who where we only confirm one hypothesis, the isochrony perception interpretation. We will use this new evidence using an alternative paradigm to probe beat perception and also isochrony perception to update the gradual audiomotor evolution hypothesis. Here the results are summarized, and you see that basically beat perception is something that evolved relatively recently. There is evidence that we shared some aspects of that with chimpanzees, dating the origins of beat perception to roughly 6-7 million years ago. There's also some evidence in gibbons that would suggest it's even older, 18 million years ago. But we have now confirmed multiple times that macaques are not sensitive to the beat, but they are sensitive to isochrony. And with them, we share a common ancestor 23 million years ago.